This video will cover the review for exam 1, pre-calculus 2, dual credit, math 2412. So this is an exam that my students from last year took. That was the first exam, and they took it without a calculator. Okay, so it's not only you. They also took it without. So of course, first thing you need to do is write your name. Right? No, don't forget that.
That's very important.
Very important. Okay, so let's see. Convert each angle in degrees to radians or vice versa. So right here we go from degrees to radians, here from radians to degrees. So of course we know that unit conversion factor, right? Let's focus on radians first. So I know that I somehow want to cancel pi, so I'm going to have pi on the bottom. And so this one will be the reciprocal of that. So pi will go on top and 180 on the bottom. Pretty easy, right? So then we multiply, and here we can see that we will have 180 pi over 9 pi. And so pi divided by pi is 1, so we may say they cancel. And then 180 divided by 9 will be 20. 20 degrees. That's it. The units came from here and here. Okay, so right here what we have is 18 degrees will cancel. And so we will have 18 pi divided by 180. So both numbers, top and bottom, are divisible by 18. So on the top, I will just have 1 pi. And on the bottom, I will have 10. And that's it. That's the end. Okay, next one. The question says here, for each angle, find a positive angle that is less than 360 or 2 pi, and that it is coterminal with a given angle. So coterminal, it means that they have the same initial side and the same terminal side, but they might have more than one rotation, or it might be a negative angle, right? So in this case, when you answer this question, you have to make sure that your answer is positive and that your answer is between 0 and 2 pi or between 0 and 360. Okay? Yes?
So would it be 540 minus?
Oh, well, let's subtract. So what you do here is you subtract multiples of 360.
Oh.
So if we just subtract 360 times 1, it will be what? 35. 35 degrees. So 35 is coterminal, meaning it will look like something like this. 395 will be a complete turn, and then 35 more right there. And so the angle 35, that would just be from here to here. So they both have the same initial and same terminal. Okay? It's just that the first one has one more rotation. Okay, now for the next one, it's in radians. So instead of subtracting multiples of 360, we will subtract a multiple of 2 pi, because that is a full rotation. So let's see what we get if we subtract 2 pi once. We will have 23 pi over 5. And so right here, if I have 2 pi over 1, if we convert that to fifths, it will be 10 pi over 5, right? So I think, well, let's see. We will get 23 pi minus 10 pi will be 13 pi over 5. Is that less than 2 pi? No. No, right? Because 13 pi over 5 goes over 2 pi. 2 pi in fifths will be something like 10 pi over 5, correct? So this one is over, so that will I will count that answer wrong. So what you should do instead, subtract 2 pi twice. So right here, let's multiply that by 2. So we are actually subtracting not just 2 pi, but we're subtracting 4 pi. So if we subtract 4 pi, convert that into fifths, 20 pi. So 23 pi over 5 minus 20 pi over 5, because this is equivalent to 4 pi. Do you know what this is? It's not an 11.
It's an equal sign.
It's an equal sign, vertical equal sign. The first time I saw that was in matrix algebra. I was like, what the heck is she doing? But yes, an equal sign.
It's like a bond, double bond.
Like chemistry, yes. Okay, so then 23 pi minus 20 pi, that will be 3 pi. And of course, we're talking about fifths. And that one for sure is positive and is less than 2 pi, okay? So that is coterminal angles. Now, there's another thing that we're going to see somewhere ahead, right here, reference angle, okay? So when we get to that one, I'll point out the difference. So let's go back to problem 3. And so we have here the minute of a hand. Okay, the minute hand of a clock is 6 inches long. And it moves from 12 to 4 o'clock. How far does the tip of the minute hand move? What?
So we find the.
I mean, I know how to solve it, but I'm trying to understand.
Oh, isn't it
I don't
like-
know if I typed it wrong.
Isn't it like how we did it around the school pole, the farther out?
Yes, it's one of those. I'm glad you remember. So, what I'm trying to figure out is like the from 12 to 4 o'clock.
Wouldn't it be like 1/3? And yeah, it would be right there. The circumference by 3.
Okay. So we go from right there, right? Okay. Okay, so after checking on the book, we know now that what we're trying to find is the arc length that goes from here to here. All right, so the distance that the minute hand travel from 12 all the way to 4. All right. So what we're going to do is calculate, and one word of advice here, you need to use radians. Okay, so we know that the whole clock has a circumference. It has a circumference of 2 pi, and then of course times the radius, right? That will be the whole thing. But since we're just trying to find one of those little pieces, let's see, 12 hours, if we divide them in intervals of 4 at a time,
Would it be 2 times 3?
yes, something like that. It will be 3, right? Yes or no?
I think so.
So if you divide your clock, okay, pretend this, you have a clock and you divide it into 3 pieces. So it will go, this is 12, this is 4, and then right here, 8. Thank you guys. Okay, so we're trying to find the arc length that goes from here to here. So then, let's think about this. The whole circumference, how many radians does it have? 2 pi. So if we divide that by 3, we will get 2 pi over 3, which is what Bastian was telling us, right?
I don't know, I got it different.
So the angle measurement here in radians will be 2 pi over 3. So then that is the angle we need here, 2 pi over 3. Which way, how do you get it, Bastian?
I just kind of made it an imaginary, like 180 degree line from 3 to 9, and then I just assumed that the 12 mark would be pi over 2, and then below that one to where the 4 is
So
at,
right here we have 90,
uh-huh,
and then right here,
that would be pi over 6, even though it's like going negative, so I just added that.
that's very good. And then it's pi over 6 because if you have 2 pi and you divide that by how many hours are in the clock? 12. So that is pi over 6. So the space between 12 and 1 is pi over 6. Between 1 and 2 is pi over 6. So right here, Bastian did pi over 2 plus pi over 6, correct? Yes? And that's how he got the 2 pi over 3. So of course there are different ways for you to figure that out, okay? We might stay away from clock problems for this test. So the answer, final answer will be 6 times 2 pi, that's 12 pi. So 12 pi over 3, so that will equal to 4 pi, which is what Ruby found. Thank you, Ruby. Good job. Good job, Ruby. All right, so just remember this formula. You must memorize it and you must use radians. Only radians. Okay, now here comes the fun part. We're going to talk about linear velocity, right? And so, first of all, before we get linear velocity, we have, and this is like the problem that you were talking about, Ezekiel, like when we were running outside. So we have the Ferris wheel, and it has a radius of 25 feet. Okay. You don't need to do this on the test, guys, please.
Can we?
If it helps you visualize something, go for it. Okay, and so it's rotating at 2 revolutions per minute. What does that mean? What is 1 revolution?
4 pi.
No, well, in total is 4 pi, but 1 revolution
2 pi.
is 2 pi. So if this one is doing 2 revolutions, that will be 4 pi. Remember, 1 revolution is 1 complete turn. So what this means is that this little guy here, every minute, is going around twice.
That's pretty.
Okay. Wow, that's pretty fast.
Yeah.
So let's go ahead and find the linear speed and feet per minute. So first of all, we have to take the 2 revolutions per 1 minute. And how do we go from revolutions to radians per minute? Do you guys remember?
180, well, wouldn't it be 180 over pi?
2 pi.
I mean, 2 pi over.
So just multiply by 2 pi. That's it. That's all we do.
Is that what we get the 4 pi?
And so that will be 4. And this will be 1 revolution. We have to be careful with the units. So 1 revolution is equal to 2 pi. So right here we cancel the units. And we will get 4 pi per minute. That right there is the angular speed. And I believe we were using, was it omega for that? Yes. I'm not very picky about that. Now let's find the linear speed. And so the linear speed, it comes from the diameter, right? We need to look into that. So linear speed, we use the radius times the angular speed, which is omega. So in this case, it will be, the radius is 25 feet, and we multiply that times the angular speed, which was 4 pi per minute, and so that will give us 100 pi per minute, and then, 100 pi feet per minute. Let me write it down here. So 100 pi feet per minute. And remember, the bigger the radius, the faster the linear speed will be, right? The angular speed will be the same, but the linear speed will change. Remember when we did that outside and you guys were running? And the ones who were at the end had to run faster, right?
And then the ones at the front.
And then me, I was just rotating like that. Okay. So let's see. What else? You will definitely have a problem about linear speed, guys. Okay. Now these problems are very simple, but somehow you guys, well, not you guys, but students tend to get confused. So if I'm telling you consider a point on the unit circle, my best advice will be for you to plot the point. And so we have negative 5 over 13 for the x, so that will be somewhere over here. This is negative 5 and this is negative 4. Oh, I'm sorry, I was thinking the other way. Negative 5 13s for x, and then negative 12 over 13. So I'm talking about which quadrant, guys?
3.
Okay, so I'm just going to pretend that right here is negative 5 13s. And right here, this will be negative 12 13 right here. So my point will be here. Okay, and we're going to call that angle beta. Right here, this is angle beta. And standard position, so that means starts on the positive x. And then the terminal side intersects the point. Okay, now find all 6 trigonometric functions of it. So right here we have a triangle, right? Yes? Do we all see it?
Yes.
Okay, so that triangle, let me go ahead and draw it here. And so remember, this is the x, this is the y. So we could consider this the horizontal distance, right? So that's going to be negative 5 over 13. And then y will be the vertical distance, so it will be negative 12 over 13. So first of all, to find all 6 trigonometric functions, we need to find the hypotenuse, right? Yes? Okay, so we can do that. Pythagorean Theorem, very easy. So that will be the square root of those fractions, so negative 5 over 13 squared plus negative 12 over 13 squared. And so that will be 25 over 169 plus 144 over 169. And that will equal to 25 plus 144 is equal to 169 over 169. So that is the square root of 1, which equals 1. Okay. So that's actually a unit circle, right? Because the radius or the hypotenuse happens to be 1. Right, so sine. Now, which one is the angle in question, guys? Do you guys remember?
Angle theta?
Did I draw this one?
Point B.
I think it's...
What I think I did it wrong.
That's right.
No, it's right here. Okay, it's right.
Angle
It's right.
beta.
This is the angle, right here. So right here, even though we're finding the trigonometric functions of angle beta, we can just use this as a reference angle, right? Right there. Okay. So we have sine of beta is going to be the opposite side, or I'm having a hard time saying it. It's right here, right here. So opposite to this angle will be negative 12 over 13. Hypotenuse is 1. So it's just negative 12 over 13. Cosine of beta, it will be the adjacent side to this angle, which will be right here. Negative 5 over 13. Divided by 1, so that will just be negative 5 over 13. You could also use this point as a reference, right? Because the cosine will be given by the x-coordinate, sine given by the y-coordinate. We could do that because the radius happens to be 1. So now for tangent, it's going to be the opposite over adjacent. So that will be negative 12 over 13 divided by negative 5 over 13. Or you can think of it in terms of sine over cosine. So in this case, we will have, and I'm just going to leave them represented as factors. If we use the sandwich rule here, the 13s cancel, and so we will have 12 over 5, positive or negative?
Positive.
Now, another big source of errors. Please, guys, make sure you give me the correct signs, because it really hurts my heart when I have to count it wrong. And I know you know the right answer, but you forgot the negative or the positive, and it's wrong. I mean, if you tell me I meant to put positive and it's negative, guess what? It's wrong. It's actually completely wrong because it's the opposite. It's like yes and no, like true, false. All right? So please remember, your signs go like this. Sine is positive here and here, negative here and here. Cosine is positive here and here, negative here and here. And then finally, tangent is positive here and here only. In quadrants 1 and 3. Tangent is negative here and here. Okay, so moving on. Now here, you're going to have to do the same thing, find all 6 trigonometric functions, but with a triangle. So right here for sine, I think this one is pretty easy, right guys?
Yeah.
What do you think? I will say that the trickiest part is to find the missing side because sometimes students, remember, you're solving for a side, not for the hypotenuse. So if you're solving for a side, it will be c squared minus b squared is equal to a squared. And so a will be the square root of b squared minus the square root of c squared minus b squared. All right? So when you're finding a side, hold on a minute, you must have a minus there. Yes, it does.
What about the other 3 on the top?
Oh, sorry. I'm glad you remind me. So don't do that on your test, right? Because how many trigonometric functions did I ask for? 6. And so you don't want to lose on those points. But I think you could tell me pretty easy what they are, right?
Once you have those, it's just
Wouldn't it be
Reciprocal. Yes. So this will be negative 13 over 12. And then secant will be negative 13 over 5. And then cotangent, what did we say tangent was then?
12 over 5.
12 over 5. So then cotangent will be 5 over 12. Yes.
Where are your cups?
I don't have
It's not.
Quiz for 6, don't you have to find B? Well, the B side?
Yes, we do. So that's what we were doing, but I was calling it 8.
Oh.
But you could call it whatever you want. Oh, true. A is taken. Am I confusing you? Ruben, is this stressing you? Let me rewrite it. So we were doing c squared is equal to a squared plus b squared. We are looking for b because a is taken. So b squared is equal to c squared, don't talk please, minus a squared. So then b is equal to the square root of c squared minus a squared. Okay, do not forget that you will subtract if you're finding a side. If you're finding the hypotenuse, what would you do?
You would add.
You will add. Okay. Now, so this side right here, b, is going to equal to the square root of 5 squared minus 1 squared, which happens to be the square root of 25 minus 1, which is the square root of 24. And of course, 24, we need 2 factors where 1 is a perfect square, so that will be 4 times 6. And so from here, we will take the square root of 4, that's 2, and then the 6 stays inside. So b is equal to 2 times the square root of 6. If you just want to tell me the square root of 24 because you know you're not very good at doing this, I'm fine with that. Okay? All right. So, I mean, I would hate for you to get it wrong just because you didn't do this correctly. So, you got sine is opposite of over hypotenuse, so 1/5. So, what is cosecant? Quickly. No, it's not. Cosine. Adjacent, that will be here, over hypotenuse. So that will be 2 square root of 6 over 5. Tangent. That will be opposite, adjacent. Here we need to rationalize. So we're going to multiply by the square root of 6, top and bottom. There's no need to multiply by 2 times the square root of 6. The square root of 6 is enough. Square root of 6 over 12. Now it is 12 because when you multiply this square root of 6 times the square root of 6, that will be like square root of 6 by itself, and that will equal to 6, right? And then this 6 times 2 gives me 12. Are you scared? Okay. Why are you so quiet?
Because he doesn't know what's going on.
Okay. All right. Cosine, reciprocal of that will give us secant. So it will be 5 over 2 times the square root of 6, and so we're going to have something similar to that to rationalize. Wow, you guys are getting pretty good at this. Right.
I'm getting pretty good at this.
And then cotangent. Cotangent, we need the reciprocal of tangent, and it will be in our best interest if we just take this one, right? And get the reciprocal of it. That would be the easiest thing to do. So that will be 2 times the square root of 6. Yes? Okay. So be careful with your signs. That's all I can tell you. If you're looking at a triangle, all of them will be positive. But if you are talking about a point or some particular angle, you have to check the signs. Positive, negative. Okay, now next problem. Consider tangent is blah blah blah. And we have, so first of all, we need to find out the quadrant. So we're saying the tangent is negative and the sine is what? Greater than 0. What does that mean?
That means that
Positive or negative? Okay, so in which quadrants is the tangent negative? 2 and 4. Let's use Roman numerals. Very good. Who said that? Jonathan?
Me.
Jose?
It wasn't that doesn't talk. Yeah.
Okay, and where is sine positive? Which quadrants? 1 and
1 and 2.
1 and 2. So which one repeats here? Quadrant 2. So that's what we're talking about. So that point is in quadrant 2. They're telling us what the tangent is. So with the tangent, they're telling us what the y is and what the x is, or what the opposite and the adjacent is. So we're talking about quadrant 2, and I'm going to go ahead and say that the y value is going to be positive. So it's going to be here at 1, and the x will be the negative. 1, 2, 3. How do I know? Because we're in quadrant 2. So the point will be here. Oh, it's really ugly. Is that okay? And so we trace that triangle, right? And so we have here, I know it's weird to say the distance is negative, but I'll just keep it that way so that when you do your trigonometric ratios, you tell me those ratios correctly. So in this case, sine of theta will be opposite over hypotenuse. Do we have the hypotenuse?
No.
Not yet, but we can find it, right? So that's pretty easy. That will be c squared is equal to a squared plus b squared. So c squared is equal to, let's just say c. It's equal to the square root of a squared plus b squared. So then c is going to be 1 squared plus 3 squared. So you guys are saying 10, right? Because it's 1 plus 9. And so that will be the square root of 10. Again, we rationalize, so, oh no, we can't. So we just leave it like that. So that will be the square root of 10. All right, so sine is opposite over adjacent. And we're talking about opposite of that, right? So that will be 1 over the square root of 10. We rationalize, and we will get the square root of 10 over 10. I'm going to erase this part, so I won't need it.
Maybe if you put down a marker.
All right, let's move on to cosine. Cosine is adjacent, so that will be the -3. Now, this is where you need to be careful. If we are in quadrant 2, you must make sure that your cosine and your secant are what? Negative. So we rationalize here, and we will get -3 times the square root of 10 over 10. So right here for secant, that will also be negative, and we could just take the reciprocal of this one right here, right? So the square root of 10 over 3. You must make sure those two are negative. What else is going to be negative here? Besides cosine and secant?
Tangent and cotangent.
Tangent and cotangent. Okay, so tangent will be, we already have it actually. And if you notice, how many points am I giving you here? Oh, I put 6. I was gonna say 5. But cotangent will be the reciprocal of it, so that will be negative 3. And I forgot to get cosecant. So that will be the square root of 10, right? Just the reciprocal of this one right here. What is the hardest part here? To get the signs correctly and also to get the correct quadrant, guys. The correct quadrant, that's the key. Right, Jonathan? If you don't have the correct quadrant, everything else will be wrong. All right, moving on. Now we get to reference angle. You guys see it here, right? So reference angle and coterminal are different. Definition of reference angle is positive, and it has to be acute, meaning less than 90, all right? And the reference angle is the angle that is formed by the x-axis and the terminal side. So it could be right here, or it could be something here, depending what your angle is. So let's read the problem. We have, find the reference angle for this angle here, 23 pi over 4, and state the exact value of the 6 trigonometric functions of theta. Do not approximate, so no calculators here, again, and make sure you have the correct sign. So let's locate 23 pi over 4 first. Let's turn it into a mixed fraction. So that is equivalent to 20 pi over 4 plus 3 pi over 4, isn't it? Yes? 20 pi over 4 plus 3 pi over 4, that's the same as 23 pi over 4. So I'm just like breaking it into 2. Why do I want to do that? Because I want to see how many pi's I get from here. So how many pi's do I get from there? 5 pi. And then here I will have 3 pi over 4. So if I want to draw this angle, it will look like this. Standard position, so we start here, positive x-axis. And then 5 pi, that means that we will go, that's 2 pi, 4 pi, 5 pi, and then what else do I need? 3 pi over 4, and so that will be like that. Yes? Because every quadrant has 2 pi over 4. So this is pi over 2. Right here we have 1 pi over 4, 2 pi over 4, right? So that's how I knew that I had to go one more quadrant and then half of the quadrant. So right there, that's where the angle is. So for my reference angle, graphically, I could say that it will be from here to here, this one. Okay? Arithmetic, but using numbers, I can't say that word right now. So the reference angle, which we use theta prime, is going to be theta minus 5 pi. So it will be theta, what was the angle? 23 pi over 4 minus 5 pi. That will be the same as 23 pi over 4 minus 20 pi over 4, and that will give me 3 pi over 4. That is one way to get it. Another way to get it, you could think of it this way. 3 rotations, how many radians is that? Yes, it starts with an S. 6. You could say 6 pi minus 23 pi over 4. 6 pi will be in fourths. That will be I feel like we're doing something wrong. This is wrong. This is the correct one.
So So,
Wait, let me finish and then I'll tell you why the other one was wrong. So 24, 6 pi is 24. Is 24 over 4, 6? Okay. So we have that minus 23 pi over 4. And so that will be pi over 4. So my bad. The answer for this question should be pi over 4. That's the reference angle. So why is this one wrong? Because, first of all, I'm tired.
It's not acute.
It's not acute, yes, that's one good reason. This angle is greater than 90 degrees or greater than pi over 2. Also, because that's the one that we calculated from here. Let me get another color. From here to here. The first one that I did. This is wrong, guys. My apologies. Yes.
so it always has to be higher than the reference angle? I mean, well, that angle? 23 pi over 4.
It has to be, as long as it is positive and it is acute, it's good. So let me give you another example. Let's say I ask you 15 pi over 3. No, that one's easy. That's just 5 pi. Let's make this a 16. So that will give us a 5 pi, and then pi over 3. Let me think of something different.
Use a prime number.
So you basically would be able to do the line, basically do what you do with the numbers.
Okay, let's say 5 pi over 6, something like that. 5 pi over 6 is right here. Yes? So if I ask you, what is a reference angle to that? The reference angle will be formed with the terminal side of that, of 5 pi over 6, and the x-axis. So in this case, you will say pi minus 5 pi over 6, and the answer will be pi over 6. So it depends, like, where your terminal side is, if it's in quadrant 1, 2, 3, or 4. Well, if it's in quadrant 1, you don't need a reference angle to begin with. Okay, did we answer the question?
No.
Not all of it.
Oh. Oh, it's pi over 4. I like that one. So if the reference angle is pi over 4, we know all trigonometric functions, right, for that one? Do we know sine of pi over 4? And the cosine is the same. And where's Sean? Where's Sean? He's not here. What's tangent of pi over 4? 1. He knows that one very well.
And he just guessed.
Okay, so sine, not of pi over 4, but of this angle here. What was it? 23 pi over 4. So that will be the same as pi over 4, but what are the signs going to be like? If it's in quadrant 4. The sign will be positive or negative? Negative. How about the cosine?
That would be positive.
How about the tangent?
That would be negative.
Negative 1. And of course, you know that cosecant, secant, and cotangent will be the reciprocals, right? Yes? Is it okay if I skip that? Yeah. Okay. Moving on. So you're going to have to graph something. In this case, my graph is sine. You could have cosine on your test. So what I'm going to do is the amplitude right here. Well, quickly, what is the period? 2 pi. What is the amplitude?
3.
The absolute value of negative 3, which is 3. What is the domain? All real numbers. What is the range?
That would be negative 3 to positive 3.
But what if I add a 1 here?
You should.
Oh.
It would be negative 2 to
That will shift everything up. So it will be -2 to 4. Okay, so be aware of those. Just saying.
We use brackets for the range?
Yes, because those points are also included.
Okay.
For the parent function, it will be -1 to 1. But since I have a 3 here, that changes the amplitude. All right, and then it says complete 4 periods, and then graph the reciprocal. Write the equation of the reciprocal. What is the reciprocal of sine, guys? Cosecant. So that will be -3 cosecant of x. So to graph, now right here, I will do something with the x-axis so that you could just label them to your convenience. But what you will have here, you can make this one 2 pi if you want. This will be pi. So the sine function starts here, and it ends here at 2 pi. Right here's the max, here's the min. And so you graph them. It says to graph how many periods? 2 in the negative and 2 in the positive. So that means that you need to go 4 times like that. All right?
So we go to 4 pi and -4 pi?
Correct. So that is 4 pi. And then right here, this will be, oops, one more, -4 pi. Now when I tell you graph because I also ask you to graph the reciprocal. It says right here, graph them on the same plane. Those are pretty easy to graph. In case you forgot, we do have asymptotes anywhere where the sine function has an x-intercept. Cosecant will have an asymptote because it's like you're dividing by 0, right? So that's undefined. And then how do you graph cosecant? You just do this beautiful thing right here. Anywhere where there's a max for the sine function, you will have like a parabola opening up. And anywhere you will have a minimum on the sine function, you will have like a parabola opening down. Okay, pretty easy. Let me see, what else is very important here? Right here, remember I told you sometimes you can just cancel, others you cannot. Okay, so let's see if we can. It's very important that you remember this. For sine, we use numbers from pi/2, actually from -pi/2 to pi/2. That's for sine inverse. For cosine inverse, we use from 0 to pi, including those. And finally, for tangent, we use from -pi/2 to +pi/2, but we do not include those. So it's open circle. So right here, could we just cancel?
Yes.
Okay. The answer is
0.
0. Let's see if it's true. What is the answer for the inside? Sine inverse of 0. So at which angle is the sine equal to 0? Look at the origin right there on the graph. At 0. Could I say 2 pi? It's also true, but it's not in between this range. So no, I cannot say 2 pi, 0. And what is the sine of 0? 0.
Yeah.
Could I cancel here?
Yes.
Actually, yeah. So I might give you a problem when you cannot cancel. So I would suggest you look those on your notes. Okay? Yes, I will. You know me.
Is that our test?
Yeah, that was your test.
They're just easy. They just cancel.
It would be pi -5.
Not fair.
Okay, it's not fair. Now, right here, guys, sine of pi/3, that is the square root of 3/2. Cosine of pi/4 is the square root of 2/2. And then the tangent of pi/4 is 1. So what you need to do is, of course, multiply here. So that would be the square root of 6/4 minus 1. And you can just leave it like that. I don't have a problem with that. Okay, and then right here, the very last one, so you can go. That's the answer. I'll leave that one for you to do.
The test, is there going to be like
Okay, let me finish this one so everyone can go. Okay, go ahead. If you're not writing the class, please stay. Use the right triangle to write, don't make noise please, exit quietly. Use the right triangle to write each expression as an algebraic expression. Assume that x is positive, blah, 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 blah. Okay. We need a triangle, right? So let's say this is theta. So sine theta is equal to 2x. Actually 2x over 1. Sine is opposite over hypotenuse, right? So the opposite to that is 2x. And the hypotenuse is 1. How can we find the side right here? Pythagorean Theorem. So a squared is going to be c squared minus b squared. Remember? Minus. So a is the square root of c squared minus b squared. So a is the square root of 1 squared minus 2x squared. So a is equal to 1 minus what? Right here, the square, you need to square the 2 and you need to square the x. So that will be
4x squared.
4x squared. So that goes here. Okay, and then what is the question? Oh, this is a question, sorry. Okay, so now, remember we have to answer from the inside out. So what is the answer to this part? Theta, that's it. We don't really care what theta is. It's just theta. Now, what is the cosine of theta? Adjacent over hypotenuse. So it will be the square root of 1 minus 4x squared over hypotenuse. So the answer is just the square root of 1 minus 4x squared. And that is the last problem, right? Oh, gosh. Really?
Oh wait, there's more. Where's that from?
I think those are easy. Maybe that one. Maybe that will be a little. Actually,
From Billy Mean.
I just remember there's a trick to both. Okay. Are you guys like you're getting picked up? Are your parents already here? Okay. So if they're already here, just go, and you can watch the end on the video. Okay. If you can stay, I'll just go over these 2 problems right now. Okay, so this is one of those bearing problems. So you have a boat, it leaves the entrance, blah, blah, blah. It travels 40 miles. Please don't make noise as you exit. On a bearing south 64 east. So that means we're going to go 64 degrees right here. So this is south and this is east. How many miles south and how many miles, what? I made a typo there. Oh no, I just typed it twice. That's what I did. It's right here. And how many miles east? It's right there. From the harbor has the boat traveled. All right? So we know this distance right here only is what? 40. 40. Thank you guys. 40 miles. And so the question is here, how many miles south and how many miles east? That's what we're looking for. All right? So, of course, we need this angle here, the bearing, because with that, we could use any trigonometric function, right? So, right here, the 40 miles represents the hypotenuse of this triangle. So, we could say, let's say we want to find this one. So, that will be opposite to 64 degrees. So, what can we get with opposite and hypotenuse? Sine of 64 degrees, it is opposite over hypotenuse. So in this case, with our numbers, the sine of 64 degrees will be the opposite, which is A. We call it A over 40. And then, of course, here, to solve for A, we approximate, it will be 40 times the sine of 64. Make sure when you will do this problems on Friday, make sure you have a calculator in degrees, okay? Degrees. I'm not going to give you the answer, you can find that on your own, but that will be the answer for east, right?
Yes. And then we would use that sign.
So
Actually, we should probably find it.
we would
Anyone
use
has a
that-
calculator?
We can use.
Yeah.
For Friday.
Oh.
This is Friday, yeah. Give me a calculator,
How many problems can we use?
Antonio.
It's so
I'm probably going to try to, probably the same as this test.
So how many use it in the first one?
You know what? I don't know. This test has 14. So for Thursday, or Wednesday, you'll probably have around between 10 and 12. And then Friday, you will have 2.
Oh, okay.
2 or 3.
Excuse me.
Thank you, honey.
Can I go on sleep? Or sometimes not again.
All right, Alexis, you almost got it?
What is it? Sine of 64?
Yeah.
35 point.
Wait, do I round?
So it's 36.
Okay. So 36 miles. So that will be east, right? 36 miles. Now to find the miles that it travels south, we could use Pythagorean Theorem. So let's call that B. So B will equal the square root of C squared minus A squared. B will be the square root of 40 squared minus 36 squared. Could you get that one for me, Alexis?
17.4.
17.4. A good way to check your math, because, you know, things happen, is that your hypotenuse, if you're talking about a right triangle, well, only right triangles have hypotenuse, it has to be the longest side. So if you get some numbers that are bigger than the hypotenuse, there's something wrong, okay? All right, let's just finish the last problem so you guys can go. Let's see, we have a flagpole, and I really wanted to cover it because this one has a little trick to it. Flagpole is situated at the top of a building. Here's a flag. Let's make it a U.S. flag. Okay, and so the angle of elevation, remember that, guys? From a point on level ground that is 330 feet from the building. So we're gonna go right here. And so the angle of elevation goes from this point to
The top of the flag.
top of the flagpole. Here's the trick. We're not going to the top of the building. We're going to the top of the flagpole right here.
So the other one's.
And the angle right here is 63 degrees. Now, we have another situation here. So it says the angle of elevation from the same point, but now to the bottom of the flagpole is 53. So now we're going to go from here to here, the bottom of the flagpole.
Oh, and we're finding the height of the flagpole, not the building.
So how many triangles am I going to have?
2.
I'm going to have what I'm going to call the orange triangle and the purple triangle, okay? All right, so let's look at our numbers. The angle here was 63, correct? Here we have 330 feet. Right here, the angle is 53. And here, the measure is, again, 330. Okay? So, let's assign some letters to this. So, let's call this one S, the height of the building. And then let's call the whole thing, you want to call it R? Okay, R. R. So right here, this is R. All right? So if we were to find the height of the flagpole, which is right here, what would you guys do? Well, let's pretend we already have all that.
X minus R.
X minus
R,
R?
no, R minus X.
X minus
R, like the whole thing, minus X. Okay, so that's how we're gonna find it. So let's move on. So with this one, we have opposite to the angle, and we have adjacent, right? So which one, Ruby?
Tangent.
Opposite and adjacent.
What did I think? Yeah, tangent.
Yeah, tangent. So tangent of 53 degrees is opposite over adjacent. And so to find X, it will be 330 multiplied tangent of 53 degrees. And of course, to get R,
So if you were to put it in the calculator, you have to set it to degrees.
correct, you must have it in degrees here, okay? And so for this one, again, we can use tangent, right? Because we have the opposite and we have the adjacent. Well, we're looking for the opposite, so it will make sense to use tangent. So tangent of 63 is opposite, that's R. Adjacent is 330. So how do we find R? By multiplying 330 times tangent of 63. Okay? So once you have an answer for X and an answer for R, you will subtract, because remember, we're looking for the height of the flagpole.
You want to do it?
No, it's okay. So R minus X, and that will give us this answer right here, R minus X. Okay, and that's it. That's the test. So, see, it took me 56 seconds if we round to 57. Okay, so this is the end of the video. Yeah, minutes. So,